Today let us talk about the batteries. I'm taking two cells. One is the primary cell, other is the secondary cell. Primary cell is the non-rechargeable one and secondary is the rechargeable one. So this is an example of a primary cell, the Daniell cell. It is an electrochemical cell. In this you can see here in between is the cell carbon rod or the graphite rod, which is placed at the center. It will be acting as a cathode, and it is surrounded by a wing which will be acting as a anode. And here you can see MnO2 is there with C and a paste of ammonium chloride and ZnCl2, which will be acting as electrolyte. Now let us see the reaction which is occurring. At anode there will be oxidation, zinc will get converted into Zn+2. At cathode there will be reduction in which ammonium ions will react with the MnO2 and they will give you a complex that is manganese oxyhydroxide. During that process ammonia is also released. Now this ammonia which is released, zinc chloride will react with this ammonia, resulting in the formation of complex. Otherwise what happens is that the pressure which is developed due to ammonia, it can crack the seal of the cell. Now let us talk about the mercury cell, which is also known as the button cell. It consists of anode which is made up of zinc and cathode is made up of mercury oxide. Electrolyte will be the paste of KOH and zinc oxide. Now in anode there will be oxidation, which you can show like this, that is zinc undergoing oxidation to give you Zn+2, or you can show zinc mercury also in presence of KOH OH, giving you ZnO and water. At cathode there will be reduction in which mercury oxide in presence of water will get converted into Hg and OH. Now when you see the overall reaction, whatever is cancelling, that you will cancel. Water is going, electron is going, OH is going. So overall reaction will be zinc mercury, HgO, ZnO plus Hg. This cell has greater life as compared to Leclanche cell, as there are no charges involved and the voltage is 1.35 volts. Now let us talk about the secondary cell, which is rechargeable, and best example is of lead storage battery, that is the car battery. Now you can see the cell here. It is having lead plate which is acting as anode and PbO lead oxide which is acting as cathode. So lead, lead oxide, lead, lead oxide, lead, lead oxide, and so on. And electrolyte will be 38% of sulfuric acid. Now at anode you can see there will be oxidation reaction, Pb getting converted into Pb+2 and that reacting with the SO4 2- to give you PbSO4. So this is the overall reaction for anode. At cathode there will be reduction process, that is PbO2 in presence of 4 ions of hydrogen will undergo reduction and get converted into Pb+2 and water. And Pb+2 will be reacting with sulfate to give you PbSO4. Now if you see the overall reaction here, that will be PbO2 plus 4H plus sulfate and 2 electrons giving you PbSO4 and 2 water molecules. So this will be the overall reaction. This is the anode reaction and this one is the cathode reaction. So whatever is cancelling, that we will cancel, and what is left is Pb plus PbO2 plus sulfate ions and H plus ions giving you PbSO4 and 2 molecules of water. So This is how the reaction occurs. Now, since it is a rechargeable cell, recharging of battery will be done by making the electrochemical cell into electrolytic cell. So reverse reaction will occur. So now this side it will be reactant and this side will be the product. During recharging of batteries, so you can see this is the reaction, that is twice PbSO4 plus 2 water molecules giving you Pb plus PbO2 and sulfuric acid. Now during recharging of battery, we generally pass electric current of a suitable voltage. Now let us talk about the nickel cadmium storage cell. It is also an example of rechargeable battery, and in fact it is having a longer life than the lead storage battery. Now in this case we are using anode as cadmium, and this is the cathode, nickel hydroxide. Electrolyte will be KOH and NiO2. At anode there will be oxidation reaction. So in presence of OH it is occurring, so cadmium will get converted into cadmium oxide. And at cathode there will be reduction, resulting in the formation of a nickel hydroxide. So when we see the overall reaction, this will get cancelled, and we are left with Cd plus NiOH whole thrice, giving you CdO water and NiOH whole twice. Now in this there is no formation of gaseous product, as you have seen in the lead storage battery. In that, ammonia was formed, and the product, it sticks to the electrode and can be removed by recharging the cell. Now here the potential will be 1.4 volts. Let us now discuss the fuel cells. As the name suggests, here the energy will be converted by the combustion of fuel, and generally fuel like hydrogen, oxygen, carbon monoxide, then methane, they are taken. Now in this, the voltaics, these are the voltaic cell in which the reactants, they are continuously supplied to the electrodes. And the best example is hydrogen electrode fuel cell. You can see here, this portion is anode, this portion is cathode. Here the electrolyte which is taken, that is KOH. Now H2 and O2, they are continuously supplied. They are bubbled through a porous carbon electrode into the concentrated aqueous solution of either KOH or NaOH. And hydrogen will be fed into the anode compartment, and where it will be oxidized. These are the reactions which are occurring in the anode and the cathode cells. Here one thing we have to see is that the diffusion rate of the gases into the cell, they are carefully regulated to get the maximum efficiency. Now you can see here, at anode H2, it is reacting with the OH, giving you water molecule. At cathode, oxygen will be reacting with the water to give you OH. So overall reaction will be H2 reacting with O2, giving you water. Here the electrode is porous, and it is compressed carbon which is containing small amount of catalyst like platinum or silver or cobalt oxide. It can be used as a catalyst. Now when we talk about the fuel cells, they are having very high efficiency. They can convert energy of a fuel directly into electricity, and there is continuous source of energy. So it can be used in even spacecraft, and it is pollution free.